Pappy Bowenton's dogfight with a group of Japanese Zeros over a ball in 1944 is far more than a test of piloting skills. It's also a battle between aircraft and technologies. On one side, there's the Mitsubishi Zero, which early in the war was the undisputed champion of the skies in the Pacific. But by 1944, the technological edge that helped make the Zero dominant has almost disappeared. Built to maximize its offensive capabilities, the Zero is maneuverable and well-armed. However, it lacks defensive features like armor plate and self-sealing fuel tanks, which are found in U.S. fighters like the F4F Wildcat. Yet even though it's been overtaken by U.S. designs in many areas, the Zero is still an extremely effective dogfighter, especially at lower altitudes. On the other side, the chance-fought F4U Corsair is starting to carve out a legend of its own as one of the great naval fighters of its era. Like all other contemporary U.S. fighters, the 9,000-pound empty weight of the Corsair is considerably heavier than the 4,000-pound empty weight of the Zero. That means it needs an extremely powerful engine to keep up with a Japanese fighter in combat. Fortunately, the Corsair has one, and it's among the best aircraft power plants ever built.
Good to see you again, Mark.
Yeah, likewise, Max.
So here we are at the Corsair, and man, this thing is huge. This is a big plane, and it starts up front with the engine. So give me some stuff that you know about the engine.
Yeah, it truly is immense. We've got a 2,000 horsepower Pratt & Whitney engine on the front of this thing. We got a prop that's being turned by this engine. It's 13 feet 1 inches in diameter.
Holy cow! I mean, it's got to be one of the larger engines of the day. So was the engine supercharged, turbo? What was it?
There's no turbochargers on this. It's all supercharged, internally supercharged, and it's a 2,000 horsepower engine.
Wow. I mean, is that fairly powerful for the day? Wasn't it one of the most powerful engines when it came out?
Most powerful aircraft at the time. The other airplanes that are comparable would be the P-47 Thunderbolt and the F-6F Hellcat. Both had the same R-2800 2,000 horsepower engine.
When the R-2800 becomes available to chance-fought in 1938, designer Rex Beasel and his team are given a simple mandate: to build the most streamlined yet rugged structure possible around the engine. They succeed wildly. In fact, when the prototype of the Corsair is flown in May 1940, it becomes the first U.S. single-engine production aircraft capable of topping 400 miles per hour in level flight. In addition to its high speed, the Corsair also proves to be an excellent performer at high altitude. The piece of technology that allows this is the engine supercharger. Superchargers are basically gas compressors that force more air, and thus more oxygen, into the combustion chambers of an engine as the altitude rises, and the ambient atmospheric pressure drops. Unlike the turbo superchargers on fighters such as the P-38 Lightning, which are powered by engine exhaust, the Corsair mounts a regular supercharger, which is driven directly by the crankshaft of the power plant. Not only does the supercharger improve the Corsair's high-altitude performance, but it also gives the fighter a terrifying nickname.
So, Mark, you mentioned those superchargers. Are these the intakes for the superchargers?
Yeah, this is the intake for the intercooler for the superchargers, and also an intake for the oil coolers. And this intake, aerodynamically, is what gave this aircraft the whistling death nickname that it had, because it had a high-pitched whistle when it would be coming down towards the Japanese.
That's right, the whistling death. I remember hearing that before.
The Mitsubishi Zero also has a supercharger, but in the later models, it's been upgraded to maximize engine performance to about 20,000 feet, whereas the Corsair's supercharger allows it to maintain performance well above 20,000 feet. So the Corsair's massive R-2800 engine and supercharger assembly and its equally big propeller give the plane distinct advantages in speed and altitude over the Zero. However, these very same features also present several unique challenges to the Corsair's designers, ones they solve in creative ways.
So with such a huge engine, you got to build a plane that's fairly big around it, and you got to have a big prop to be able to, you know, curtail the power a little bit. But with a prop that's that big, I mean, look at how close it is to the ground. So how did they design this plane so the prop wasn't hitting the ground when it was spinning?
Well, you'll see the inverted gull wing of the aircraft, and the reason for that is to make those gear make it all the way down to the ground, but without the gear being too long. If the gear had been real long and the gear goes to retract, it would hang out the back of the wing. So instead of bringing the gear up to the wing, they brought the wing down to the landing gear.
Wow, and I guess another reason that the gear have to be fairly short and squat is because, I mean, this thing would take off and land in a carrier, so you need to have some fairly sound structural features on your gear.
Yeah, that gear would have to take a lot of landing force as this aircraft would come in and land. These airplanes were heavy, and they would come aboard and tend to bounce aboard the carrier, so that gear had to be very stout.
At the same time that the Corsair's designers are coming up with innovative solutions to their problems, the Zero's builders are trying to solve difficulties of their own. Namely, how to keep their aging fighter competitive with newer enemy planes like the Corsair. Steve Hinton shows me the modifications to the Zero.
This is a Model 52 or an A6M5. It has an uprated engine, it has shorter wingspan, has a little less fuel to it, but it was faster. It has these exhaust pipes. On this Model Zero, they put these individual stacks that converted some of the exhaust into thrust. They're called jet-style exhaust pipes.
So they were using every bit of exhaust that came out of there, and actually they transitioned it or modified it so it could actually produce thrust?
Exactly, yeah. This is probably the fastest of the Zeros. I think it had a top speed of around 350 miles an hour.
How cool is that? You know, it's kind of similar to the way we still develop fighters today, where the airframe that you have when you develop it and field it is significantly different from the one you're faced with 5 years down the road. The Raptor that we're flying now is totally different than the Raptor that was first flown in 1990. We've already started putting new capabilities and upgrades on the plane. So that's, I mean, back then they did it because they were in a war. Now we're doing it just because if we have something better, we want to put it on the plane.
Well, exactly, yeah. And, you know, the Japanese, you know, they didn't expect the war to last. So they had a production line going with the Zero, and it was established and going. And to retool and make a different kind of airplane was really prohibitive. They did develop other aircraft, but they could just keep the Zero line going and just modify it and do some significant changes along the way and still use the same tooling.
Yeah, they just didn't know what they were getting themselves into, did they?
They didn't have a clue. I don't know what they were thinking. Look in the history books, and it makes you kind of chuckle, really.
In reality, however, this approach is not as foolish or short-sighted as it appears. Japanese war planners know that because of their country's more limited resources, they have no hope of defeating the United States in a protracted war of attrition. America's industrial might and vast reserves of manpower are just too overwhelming. So they stake everything on winning the war in one swift knockout blow. As a result, many Japanese weapon systems, and especially their aircraft, are designed to maximize their range and offensive capabilities, often at the expense of defense. But once the war becomes prolonged, the Japanese simply do not have the industrial capacity to keep up with U.S. production, nor can they fuel the multiplicity of new designs. So they're stuck with attempting a series of ad hoc modifications to existing designs, like the Zero. And yet, amazingly, in 1944, the Zero can still be a highly effective fighter plane. One of the reasons is the Zero's armament. Its two 7.7mm machine guns and two 20mm cannons remain extremely dangerous. But the Corsair's 6 wing-mounted 50 caliber machine guns can also be lethal.
So you've got 6 50 cals behind you if you're going into gun a Zero or something like that.
Yeah, that's quite a punch there when you have the 650s. We got a Japanese Zero that has no armor plate and is a lightweight little airplane. Those 650s could just tear through it in a heartbeat. Well,
that's a great luxury to have. Now, I would assume most of the rounds were stored in the wings. Was there any fuel in there or anything else?
No, the wings didn't have fuel, just the inboard sections had fuel, and then most of the fuel was stored right forward of the cockpit.
So not only do we have a big, huge engine, but also a big fuel tank in between the cockpit and the prop.
Yeah, and that accounts for the length of this nose here. They have a fuel tank that they had to find a spot for. They found the best place for that was right on the center of gravity of the airplane. So as the fuel burned down, the airplane's handling characteristics would remain constant.
Now, I would think that, you know, besides the fact that you don't really want to have a fuel tank sitting right in front of you when you're flying a plane, for obvious reasons, that thing blowing up on you, but also the further back you drive, I would think the little tougher it is to land, especially on a carrier.
Yeah, because of the fuel tank, they put the pilot pretty far back. It's one of the airplanes that has the longest nose on it.
Yeah, so it's really tough for a pilot to see where the wire is on the carrier when he's trying to land on it. You know, I heard that this plane was actually called the Ensign Eliminator.
That's right.
All new Navy pilots have the rank of ensign. So the nickname Ensign Eliminator refers to the ensigns who either wash out of naval aviation, or worse, ones that can't land the hose-nosed Corsair on a carrier. It's a little bit of gallows humor, something U.S. fighter pilots often use to make a dangerous situation seem a little less threatening. The problem with carrier landings is the main reason the Corsair is first supplied to land-based Marine units like Pappy Boyington's Black Sheep Squadron. Yet despite its problems, when the Corsair finally enters service in early 1943, it's an instant hit. Compared to the F4F Wildcats the Leathernecks flew previously, the Corsair is far superior in virtually every way. It may not possess the tough little Wildcat's legendary ruggedness, but it's so much better in speed and rate of climb that most Marine pilots don't care. And like the Wildcat, the Corsair also has some excellent defensive features. Most notably, a heavy piece of armor plate directly behind the pilot.
Yeah, they did have an armor plate behind the pilot, and I'm sure as the pilot was getting shot at, you know, his shoulders would start to get more and more narrow as he hid behind that armor plate, but at least he had something to hide behind.
So really nice offensive features, pretty good defensive features, and overall, what a great plane. Thanks, Mark.
Yeah, thank you.
From what I've seen so far, it looks like the F4U Corsair has a big edge in performance over even the very latest models of the Zero. Does that mean Pappy Boyington will have it easy during his tangle with the Zeros over a ball in January 1944? Not by a long shot.